afternoon everyone, I'm Febriansianto. Here I want to present a paper that talks about how we understand the robustness of SSDs under the power fault. And first thing first, why we need to know about this one? Because we need to know the behavior of SSD under the power fault. We use the methodology to cut off the power when writing on 15 different kind of SSDs and use the tool to prevent the clean shutdown from the operating system, and the last will collect the results. And why is this matter? So actually this is a problem that have been happened to experience data center operation a few years ago. Power loss seems easy to prevent, but actually it really happens, and it is a big problem. And now many cloud services use SSD as their storage, and we also need to understand how the non-volatile components behave when they losing their power. So here we have the failures. In the table we have bit corruption, flying writes, shorn writes, unserializability, metadata corruptions, and dead device. From all these failures, the worst one is this one, the dead device, because the device is not work at all, or mostly just does not work. So when we try to read the data, we cannot read anything. And the most common error is this one, the unserializability. So this is the final state that the storage doesn't result the result as we expected. For example, we have the schematics right here. First we have a thread A that will write the first record. There are 3 threads that will write to different blocks. So the thread will write the first data to block number 1, and then the thread will write the data number 2 to block number 1. This is serializable. If things happen without any kind of errors, it should return A2 as the value of block number 1, But because of the error, the unserializable error, it will show A1. Instead, it should be A2, not A1. And for the workloads, we have 3, the concurrent random writes, concurrent sequential writes, and single-threaded sequential writes. From these 3, the first one, the concurrent random writes, is the heaviest one. So in that paper, they implement mostly of those tests using the concurrent random writes. And this is the proposed workflow from them. So there are 8 steps here. First, initialization. So the initialization is a step that started by the scheduler to bring a mapping table to the hard disk, to the device. And next, the worker, it will trigger a workload. So the worker will write the data to the device again, over and over again, until a certain amount of time. And while the data is being written by the worker, the switchers will wait for a random amount of time. After waiting for a random amount of time, it will cut down the power, clean shutdown, without involving operating system. And next, the worker will keep writing data to SSD, and the next step is the scheduler will stop the workload, so the worker not writing data anymore, and the switcher bring the power back on, and then the checker will read the result to know whether an error is appear or not. And this is the result of number disk for each kind of failures. We can see that unserializable writes happen more than half from the disk that we have provided before. It occurs on 8 from 15 disks. It's very contrast with the flying writes, because the flying writes is not happen at all from the 15 disks. And as we can see here, the dead device still triggered on 1 disk. So 1 disk suffer from dead device. The data nearly completely lost, around 1/3 at that time. And we can see here that 2 disks doesn't show any kind of error at all. So it's written here as none. And this is the detail of the result. So the SSD number 1 is that device, and SSD number 6 and 10 doesn't show any kind of errors at all, and nothing happened on flying writes. So from this detailed result, we can see that 86% devices, including the double quoted enterprise class, is still exhibiting error. Only 2 from 15. And this is the paper trying to show the result as single parameter histogram. So here we have number of serialization errors observed in each testing in each iteration. So we have iteration from 10 until 100, and the result is very different. For example, for SSD number 2, the value is nearly stagnant. It's not changing much by different number of iteration, but it's very different with SSD number 8, where its values is way much different according to the iteration number. Different this, of course, will act different by the test. And this is the result when we try to use the averaging workload characterization. And here we have the number of faults needed to exhibit some kind of failures. There are no flying writes at all. And that device that we see on SSD number 1 is when we try using power faults for around 136 times. We try it again, and the device is dead at that time. And here's for the 9-step approach. So the goal of the paper is to check the robustness of SSDs under the power fault. And for the metrics, we use the failures that we have explained before. There are bit corruption, flying writes, dead device, and so on. And the parameters here is different random writing time and random cutoff power time. And the SSDs is different. There are single level cell and multi-level cell. There are different blocks inside the SSD. And for the key factors, it's saying we have the type of SSD2, a single or multi-level cell, and whether these have power loss protection. So some of SSDs have one mechanism that said to be power loss protection. The evaluation technique is using measurement because they really use the device using the real tool. And the workload is like we have talked before. There are concurrent random writes, concurrent sequential writes, and single-threaded sequential writes. For the data analysis, they check whether the specified matrix is happen or not. And the design experiment is by cutting power at random time without prevention from operating system. So there's no clean shutdown. And 9, they present the result using tabular view and histogram. So the conclusion from this paper, we can say that the paper is proposed a methodology to expose bugs in block devices. They use it by using effective workloads and then actually cutting power, and then check for errors in the repowered device, whether the error is appeared or not. And they detect 6 potential types of failures, mostly in all of the disks except those 2. Okay, so that's all from me that I can explain from the paper. Thank you.